Okay, so just to recap, we are working on solutions for our ADTs, stack and queue. We are working through the signatures and the tests for the stack data structure now. We just finished queue, that's in a different video. Just one thing I want to draw your attention to is that we're working in object-oriented land here, where we assume that we've got an object or a variable that's storing our data structure and we're calling our signatures on it. And so now we are going to take a look at the stack. So a stack pushes an item on the top of the stack. And as we had with queues, when we add an item to our data structure, we want to make sure that we have a parameter. We need to know what that new additional item is. And in this case, I would say the return type is void. I don't think you need to return anything here. There could be scenarios where you might return a Boolean value if the insert or the push was successful, but that's not typical in a stack and a queue environment because we're pretty sure when we add an item to our data structures running on our personal computers that it's going to work. That's more relevant in a database scenario or a synchronous type scenario where you might request to add something to a data structure, but the computer might wait or have to juggle a lot of different competing demands before it actually gets on there. So for most instances, we're going to go with a void. So we can also remove the item from the top of the stack and return it. In that case, we'll pop. It's going to return the popped item. So that's going to be a return type item. We don't need a parameter because the underlying data structure, the stack itself, has all the information we need. That's also the same for peek. Return. So I want to differentiate pop and peek. And so I think the key here is that it's not only going to return the item, it's a destructive operation where it removes the top item as well. If the stack is empty, is the same as queues. That's Boolean is empty. We don't need a parameter because our stack already has all the information we need to determine if it's empty. And also, again, we have clear, which also doesn't require any parameters. Now let's keep moving and let's take a look at what some of these tests might look like. So for simplicity, I'm going to use an S. So let's try to push some things on our queue. So I'm going to push an A. And sometimes it's really nice to think of a stack like this, where you start adding things. But in a test situation, that takes up a lot of space and it's really actually hard to type. So what oopsies, that's the result, not the stack before the call. So what I normally do is I write my queues and my stacks left to right. You can reverse it. I will still be able to follow if your operations are correct based on how you're adding and removing them, but I prefer to go left to right. And so let's push a little bit more. So the stack before the call, the stack after, and let's add one more thing. Okay, and so at this point, things look really similar to the queue, right? They look almost identical. So let's make things different. Oh wait, hold on, I'm gonna peek first so we can see that that works the same. The result is still ABC, so I'm not gonna bother to rewrite that. The result is just simply gonna be C. And here is where it starts to get different. It's where do we peek and where do we pop? So let's try popping. Again, where ABC is our stack. And once we pop, we're going to be left with AB, and then C is going to be returned. So this is where we get different from the queue. So with the queue, when we would strip off the beginning, right? The first thing we would remove would be the A. The first thing in is the first thing out. But with stacks, It's the last thing that gets removed. First in, last out. So we're actually removing the C here. Let's test to see if it's empty. It still has 2 elements in it, so this is going to return false. And finally, let's clear it. Let's clear our stack. We started with AB, and then we're going to have an empty stack.